Determine all values of c that satisfy the conclusion of Rolle's theorem for the function f of x equals x cubed plus 13x squared minus 9x minus 17 on the interval -3 included to +3 included. The first thing to do is to determine whether the three conditions are met for Rolle's theorem to be applied. The first condition, the function f of x, which is x cubed plus 13x squared minus 9x minus 17, has to be continuous on the closed interval given. X cubed plus 13x squared minus 9x minus 17 is a polynomial. And a polynomial is continuous on any interval, so it will be continuous on the closed interval given from -3 to 3. Closed means that it includes both endpoints, indicated by the square brackets on both endpoints. Condition 1 is met. Condition 2, the derivative. First term, power rule, bring down the power, subtract 1 from it. Second term, power rule, bring down the power, multiply with the 13, subtract 1 from the power. Third term, constant times x, derivative is the constant. Fourth term, constant with no x, derivative is a 0. The derivative needs to be continuous. It is called differentiable on the open interval. 3x squared plus 26x minus 9 is also a polynomial. And a polynomial is continuous on any interval, so this will be continuous. It's called differentiable for the continuity of the derivative on the open interval. Open means it does not include the endpoints, indicated by the round brackets on the endpoints, because a function is never differentiable on its endpoints. So it will always be the open interval here. Condition 2 is met. The third condition, the function evaluated at its left endpoint has to match the function evaluated at its right endpoint. In this problem, we have the interval of -3 to 3. The left endpoint A will be -3, the right endpoint B will be a +3. So we're going to evaluate the function at the -3 and the 3 endpoints. These are evaluated by plugging them into the function. F of -3 will be -3 cubed plus 13 times -3 squared minus 9 times -3 minus 17. -3 cubed is a -27 plus 13 times a -3 squared, which is a 9. A minus 9 times a -3 is a +27, and then minus 17. The -27 and the +27 can cancel each other out. 13 times 9 is a 117, and then minus 17 comes out to an even 100. F of 3 will be 3 cubed plus 13 times 3 squared minus 9 times 3 minus 17. This will equal to a +27 plus 13 times 3 squared is a 9, minus 9 times 3 is a -27, and then minus 17. And once again, the +27 and -27 can cancel. 13 times 9 is a 117 minus 17, and so this also comes out to an even 100. We do have that f of -3 equals to f of 3, and condition 3 is met. We have all three conditions being met here, and therefore Rolle's theorem does apply. Rolle's theorem says the slope of the tangent line at some value c, f prime of c, will equal to, from the mean value theorem, f of b minus f of a over b minus a, the slope of the secant line connecting the endpoints. But in Rolle's theorem, we have condition 3 also holding true, where f of a and f of b are the same value, so that when they subtract here, they equal to 0. Rolle's theorem is the special case where f prime of c equals to 0 for at least one, perhaps more, c values in the open interval of -3 to 3. We are going to solve for every c value and keep those that are in that interval. We're guaranteed at least one, perhaps more. The left side, f prime of c, is evaluated by plugging c into f prime of x. That will give 3c squared plus 26 times c minus 9 equals to the right side is a 0. We have a trinomial quadratic. We will need to factor this. There is no common factor. The numbers are not going to be divisible by any common divisor. So we just have to factor it as is. Because it's 3c squared, it'll factor into a 3c and a c. And we need two numbers that multiply to be a -9 and add to be a positive 26 after one of them is multiplied by a 3. 9 has factors of either 9 and 1 or 3 and 3. 9 and 1 will work if the 9 is put here and the 1 is put here. That will give a 27c and a 1c, which can add to the 26c as long as the 27 is positive and the 1 is negative. That means we will want a positive here and a negative here. Now that it's fully factored, each factor can equal 0, so 3c minus 1 can equal 0, and c plus 9 can equal 0. Solving the first one, add 1 to both sides, divide both sides by 3. Solving the second one, subtract 9 from both sides. And there's the possible c values. We only keep those that are in the interval. We're guaranteed to have at least one be in that interval. The first one, c equals 1/3, is definitely less than 3, and it's definitely greater than -3 since it's not negative. So this one is in the interval. And then -9 is more negative than -3, so we do not keep that one. And therefore we end up with one value, c equals 1/3, that satisfies the conclusion of Rolle's theorem for this function.